Hello everyone, this is James Shore with Let's Code Test-Driven JavaScript. I'm here with my lessons learned about JavaScript Workflow in 2015. In this episode, we're going to cover what you need in order to get started with a great development environment for front-end JavaScript. We've covered this material in various parts of the screencast before, but it's been a couple of years since we really went through it, and I want to update it to the latest standards for 2015 and also just bring everything together. Don't hesitate to go back and look at some of those earlier videos. Some of the details about tooling is out of date, but the important thing to learn from this video and those is not so much the specifics of the tools we're using, although I am going to update it to the latest tools that I recommend in this video. But the tools aren't really the important thing. Tools change all the time. What I want you to notice as you're watching this video is the approach we take and the ideas, theory, and philosophy, the purpose of the tools. That way, even if you're watching this several years in the future and the tools are once again out of date, you can still apply this knowledge to the latest tools out there. We're going to cover 5 things in this episode. First, a reliable, reproducible build, then continuous integration when you're working with a team of developers. Then we'll look at linting, front-end modules, and cross-browser testing. This is a huge episode and there is a lot of content here, but don't worry, you don't have to watch it all at once. This is really more like 8 episodes back to back, and each one is only about 5 to 15 minutes long. So go ahead and use the timestamps here to jump ahead to sections of interest or to come back in the future. And as always, the source code for this episode is available here at the link on your screen. In this case, I refer you to the Automatopia seed project that I've set up on GitHub. It has everything we're going to cover in this episode and some more things that you might find useful. Thanks for joining me. Let's get started. We're going to start out by creating a reliable, reproducible build. This is particularly important in a team environment, which I'm going to assume that you're in, where you have multiple people on your team working on the same project. In that environment, it is absolutely crucial that given the same code, everybody sees the same results. And that seems pretty obvious, right? You know, if I give you some code and you try to make sure that it works, it should work the same way that it does for you, that it does for me. That's actually surprisingly difficult. And that's where the reliable, reproducible build comes in. A build or an automated build is just simply some sort of script that you can run that tests your code and makes sure it's all in a consistent state. We're going to look at 4 aspects of this. First, version control. Second, dependencies and how you deal with them and make sure that they are reproducible and reliable. Third, the automated build itself. And fourth, what do you do about external dependencies, things that you can't rely on to always be reproducible? How do you handle those situations? Now, the very first step is to use version control. And if you're not familiar with version control, check out this lessons learned right here. We're going to use Git, which is covered in that episode. I'm not going to go over the details, but we are starting with a completely empty project here. It's called example. I'm using WebStorm as my IDE. You are welcome to use any editor or IDE that you want. And we're going to be doing some work on the command line. So if you're not familiar with the command line, this is a great opportunity to get familiar with it. It's not that complex. If you're not familiar with it, it probably looks scary, but actually this is just a really powerful tool for automation and scripting. Very first thing we're going to do is create our Git repository by initializing it. And then what we're going to want to do is check in some basics. I'll make a README that just has our project name. And we're also going to want to look at ignoring a file. Now, if I do an ls-la or a dir on Windows, or in my case, I've got that mapped to ll, you can see that we've got 3 files in here. Git file, which is where the Git repository is stored. The idea directory, which has all the configuration information for WebStorm, and the README we just created. Before we check this in, I need to ignore some files. Now, you could ignore all of WebStorm, but I actually want to have most of the WebStorm configuration shared amongst all the members of the team because there's going to be useful things that everybody will want to have. There's one thing in there that I've learned, though, that we don't want to share, and that's this workspace.xml directory. This changes all the time, and it has stuff that's just specific to each individual computer. So what we're going to do is we're going to ignore this. Tell Git not to check that in. And the way we do it is by making a .gitignore file. Git will ignore anything it finds that's in this file, one file per line or one concept per line. So I'm just tell it to ignore workspace.xml. Then I'll tell Git to add everything to the repository, and you can see we've got our Git ignore, our IDF directory, but not the workspace.xml and our README. This is what it's about to commit. Now I will go ahead and tell it to check that in. That will be our initial commit. So now we've got a repository set up. That's what we're going to use to coordinate, to share the code amongst everybody on the team. You, of course, are welcome to use something else other than Git. Again, the tools are not the critical thing here. The critical thing is the way we're approaching the ideas. Next thing we want to do is get an automated build set up, and we will need a build tool for that. Before we install that build tool, though, we need to get npm set up and working for us. Now, npm is installed along with Node, which if you haven't installed already, go ahead and pause the video and install it now. I've got Node installed. You'll probably have a newer version, and Node comes with npm, so you can see that I have that installed as well. We're going to use npm to install a build tool, but we're going to want to have npm save off information about which versions of the various tools it's installed, and it does that in a package.json file. Now, I'm assuming that you're just creating an application that is private to your team's work. You're not creating an npm package to share with others. So for this, what we're going to do is create a package.json file for npm. Has your application name, version, and we're also going to want to say that this is private. And that's all there is to it. Now that we have this, npm will store its package versioning information in this file. So let's go ahead and add that to our Git. Now it's time to install our build tool. There's a couple of things I do here that you may find unusual. First, there are several build tools out there. There's actually a lot of build tools out there. The most popular two are Grunt and Gulp, but I'm not going to use either one of those. Now you, of course, again, use whatever tools you like. It's more about the way we approach these ideas than the specific tools, but I'm going to show you the ones I prefer the most in this episode. I actually prefer a tool called Jake, and the reason is that Grunt is a very popular tool and has a great plugin ecosystem that makes it very easy to get up and running on tasks very quickly. But it uses a configuration-based approach that gets pretty ugly over time, and you don't have as much control over how things work with Grunt as you do with Jake. Gulp has used more of a regular programming structure. It's just JavaScript, but it's very asynchronous. It actually has multiple things running simultaneously, which makes it harder to figure out when things fail, harder to reason about. I want a simpler approach that is easier to understand and debug. It's very, very easy for automated builds to just get complex and crufty because people use them all the time, but they don't tend to spend time on maintaining them. So it's really important that you choose tools that will allow you to keep things clean. And I found that Jake allows us to do that. So that's the first thing I'm going to do that might be a little bit surprising. I really do prefer Jake to Grunt or Gulp, even though Jake is an older tool and it doesn't have the same kind of plugin ecosystem that the other tools do. The second thing that I'm going to do that you might find surprising is I'm going to check Jake into our local repository. Typically, tools like this, command line tools, are installed globally. You'd say something like npm install jake-g, and npm will install the tool in your path so you can run it on the command line by typing Jake, like this. The problem with that is, remember, we're trying to create a reproducible build. Now, if I install Jake in that way and create a Jake script, when I type Jake, it will work on my machine. But when somebody else on the team gets that code out of the repository and they type Jake, it's not going to work because they're not going to have Jake installed. So what I want to do is I want to set up our repository so that anybody who gets this code gets the exact same results I do. Remember, that's the reliable, reproducible build. We want them to get the exact same results I do without any additional steps. So for that reason, I'm going to install Jake locally without the -g option, and I'm going to check it into the repository. This is a bit controversial. There are other ways of making sure that people get the exact same code you do, involving shrink wrap file or maybe a local npm server. But by far, the easiest way to make sure they get the exact same bytes you do is by putting those bytes into your repository. Now we don't want to check in any binary files. The binaries will be created automatically. So we don't want to check those in. So I'm going to say ignore scripts here. That will tell NPM not to create any binaries at this time. And I'm also going to tell it to store off the information that we're running Jake into the package.json file by adding this save dev parameter. So I do that, and it is set up our Jake. It's also going to have copied some files into a .bin directory, and I'm going to just tell Git to ignore those bin files, because again, those will be created for us automatically by NPM in the future. So now I can add everything to the repository and check it in. Now that we have this working, we can run Jake by running it out of that bin directory. But first, let's go ahead and do an npm rebuild just to make sure that to see if it creates any binaries. If it does, we're going to want to add those to our git ignore as well. But in the case of Jake, it doesn't. So now we can run Jake by going npm modules Jake. There we go. It has run Jake. It says there's no Jake file, no build file. And we will get to that in a moment. But first, let's make this a little bit more straightforward. We don't want to be typing node modules bin Jake every time. And when somebody else gets this code, actually, they're going to get it in this state with no temporary files. So let me delete all the temporary files like this by doing a git clean. And you can see if I run node modules bin Jake, that file doesn't actually exist. Remember, we're creating a reproducible build here. So what we need to do is make sure that that file exists for other people. Here's how we're going to do it. We're going to come in here, and we're going to make a convenience script called jake.sh. For those of you on Windows, I'll show you how to do the Windows version in a moment. Jake.sh is going to do two things. One, it's going to run Jake for us out of the bin directory. And it's going to pass through all the parameters we pass on the command line. But it's also going to check to see if that file exists. Like this. This says, if the file does not exist, then we'll say we're going to build the npm modules, and then we'll run npm rebuild. And what this will result in is that when we type Jake on the command line, let's make that script executable. When we type Jake on the command line, it will automatically build all of our dependencies and then run Jake out of the bin file. And now it's failing because we don't have a Jake file, just like it should. So now we can run Jake anytime we want by typing jake.sh. And this is the really important part, anybody else on the team who gets this code can do the exact same thing and get the exact same result because we've been careful to set up our build to be reproducible. That's how it works. Let's do the same thing for those of you on Windows. If you're using Windows, you can do the same thing by making a batch file. Call it jake.bat. In this case, we'll want to turn off command echoing. We'll check to see if that file exists. And then if it doesn't, we'll run npm rebuild. Then once that's done, we'll run Jake and pass all parameters through. That's how we create a reliable, reproducible build without requiring people to do any sort of other setup on their machine other than just making sure they have Node, Git, and the repository. Once they have those basic prerequisites, everything else will automatically come down to them. What we have now and what we set up in the future. Now that we have the ability to run Jake, we can actually get our Jake file set up. A Jake file is, of course, where you put your automated build script for Jake. And I'm going to put it in a subdirectory. Usually this sort of stuff goes in your root, but again, it's important to keep things clean. Builds especially tend to get really crufty. So I'm going to make a build directory for all of our automated builds and a subdirectory of that called scripts. And in there, I'm going to make our build Jake file. I'm going to call it build.jakefile.js. In order for our scripts to actually run this file, we need to pass through a -f option to Jake to say that our build is in build/script/build.jakefile.js. And we'll do the same for our DOS version. Now that we've done that, we should be able to say Jake, and it runs, and it fails because it doesn't know what to do with that build script. Now, if you're not familiar with build scripts, Jake is a lot like Rake for Ruby or Make, the good old-fashioned build tool. The way it works is you define various tasks and you give them names, and then you can have those tasks depend on other things. So Jake, if you don't tell it what task to run, it tries to run a task called default. Here, what we're going to do is just have our build script say OK. I really like my build to have a clear, unambiguous success or failure. And one of the ways I do that is by having it say OK or build OK when it's done. And I put the blank lines so that it separates from all the other output we might get from our Jake file. So there we go, a successful build. Now I will often go one step further and put in some timing information by pulling out our current time at the beginning, calculating at the end how many seconds have elapsed, and then outputting that down here. And the reason is that in an agile development environment, where you're doing test-driven development, you're going to be running this build script very frequently. Once it starts getting more than about 5 seconds, it's painful. So just seeing how long it's taking is something that I find helpful. So right now, our build script is very fast because it's not doing anything. But that's the beginning. That's sort of the basis of our automation. Now, there's one more thing I want to do before we're done creating the beginnings of our reliable, reproducible build. And that is, I want to check on another dependency. Now, we check all of our dependencies into the repository as much as possible. But you may have noticed there's a really important dependency that we are not checking in. Specifically, Node. And I've actually worked with teams that have created virtual machines that they check into the repository and work really hard to create a truly reproducible build. However, that's a lot of work, and it really does make very large repositories, which you might not want. So instead, when I've got something really big like this that I depend on, but I don't want to actually check it in, to create that reliable and reproducible build, I won't check that thing in. I'll just say in the README, for example, that these are prerequisites, and then I'll often provide information about how to build once you've done those prerequisites. The problem with this is that it's very possible in a team environment, especially with a tool like Node that upgrades very frequently, it's possible to get into a situation where the code works on my machine because I'm using Node 0.10. whatever, but it doesn't work on your machine because you're using 0.10. older version, and there is actually some subtle bug that affects our code. This really does happen, and it happens more often than you might think. So in order for us to have a reliable, reproducible build, we need to be running the exact same version of Node. But we're not checking Node in, so we can't ensure that we have the same version. What I do in this case is I create a build target that checks the versions for us. So I'm going to add a build target that runs before default. This says that in order to do this task, we must do this task once first. And here I'll just say check Node version. And so now you can see that when we run Jake, we're going to check the Node version, and then if that works, the build will be okay. Now, I'm not going to spend time in this video showing how to check the version. You can get that from the Automatopia source code that goes along with this video. I'm just going to go ahead and copy that code in right now. I'm going to go ahead and put that into a util directory under our build. And you'll find yourself making little utility functions like this all the time as you work. It's actually a really important part of how you can keep things clean when you're making a build, is factor out your helper functions into these sorts of files. So you can see here it's just some code to check the version. And the way I'm going to use that is, first, I like my builds to be concise but descriptive. So I'm going to say that it's checking the node.js version. And then some of the tools we're going to use put out dots as they do checks. So I'll just put out a single dot here saying, hey, the check's happening. And then I'm just going to use that package, that module I just added. So let's require it. And if you're new to JavaScript or Node, it uses something called CommonJS that allows us to require files from other files. So I'm going to say require build util version checker, like this. And then we have that. I can say version.check. This is the code I've written. And I've written it in a particular way that I tend to like, at least when I'm working with Jake. A bunch of options followed by the function to call when it's complete and a function to call when it fails. And we'll tell Jake that this is an asynchronous task, that it needs to wait for complete or fail to be called before it's done. Once we've done that, I will tell it that it's checking the version of Node, that the expected value is, well, we're going to put that in our package.json. So we'll require our package.json, and we'll look at the engines.node parameter, because that is actually a common thing that we'll put in our package. And then the actual value is whatever the current version of Node is, which is in process.version. And I'm going to tell it to be strict. In other words, fail unless we get this exact version. Because again, we want this to be a reproducible build. We want everybody to see the same results. So we need to have everybody be on the same version. There are some cases where you don't want it to be a strict check, but in most cases, you will want it to be a strict check. So now that we have that in there, we can modify our package.json to have the engines parameter. And we'll tell it that our current node version is 0.10.32. And now when we say Jake, it should check the version number. It didn't though, because I made a mistake. I forgot that the require is a relative path. So it's from here to here. So it should be ... /util/ version checker. Let's try that. Okay, and that version checker needs us to install the semver package. So I'll say ignore scripts and save dev. And there we go. We're checking the Node version. And if I change the version that we're using, let's say that somebody else upgrades Node and changes the engine here, because of course their build will fail because it won't match. So they'll change the engine here, check it in, I get it, and I try to run their code, and I will get this message here. Incorrect node version, expected 0.10.34, but was 0.10.32. And that's how we ensure that everybody stays exactly in sync. I'm going to go ahead and check this in. Do an npm rebuild to make sure that semver doesn't have any binaries. Pretty sure it doesn't. It doesn't, so there's nothing we have to add to our .getignore file. So that is the reliable, reproducible build. Again, what we're doing here is we're making sure that everybody gets the exact same bytes, and that with one command, by just typing Jake, we ensure that everybody's on the same version. Now that we have a reliable, reproducible build, we need some way for people on the team to share changes with each other. And not only do we need them to share changes with each other, we also need them to do it frequently. Particularly in an agile environment, the longer you wait between sharing changes or integrating, the more likelihood there's going to be some sort of conflict between files that's really painful to deal with. The reason for that is that in an agile environment, what we have are collective code ownership and merciless refactoring. In other words, anybody or everybody on the team is expected to make changes to any part of the code base, and they're constantly looking for opportunities to improve the code by refactoring, and that leads to changes. However, with all these changes happening all the time, if people aren't sharing their changes back to each other, then those changes are going to conflict. Somebody's going to do a refactoring over here that changes the name of a variable. Somebody else over there is going to do a refactoring that puts that variable in a different file. Now, when you try to bring all those changes back together, when you try to merge them together, it's going to be a really painful merge conflict. One option is to just simply not do that kind of refactoring and collective ownership. But that's not a really good idea because all that refactoring and ownership and so forth leads to improved code quality. It's constantly paying off technical debt and improving the quality of the code, and that makes you go faster. So in an agile environment, we really want that collective ownership and the merciless refactoring. So we need to make sure that we integrate everybody's code, we merge everybody's changes on a frequent basis. This is continuous integration. You've probably heard of it. Unfortunately, these days, when people talk about continuous integration, what they're typically talking about is continuous integration tools or CI tools. And those tools, well, they get it wrong. And this bugs me. Let me go back to the original introduction of continuous integration by Kent Beck in Extreme Programming Explained, first edition. He describes continuous integration in this way. No code sits unintegrated for more than a couple of hours. At the end of every development episode, the code is integrated with the latest release and all the tests must run at 100%. So that's continuous integration. Everybody merging their code back together every couple of hours and ensuring that that code is known good, that it passes 100%. It's the known good part of this equation that tools tend to get wrong. The process for continuous integration is pretty straightforward. First, bring all the changes that everybody else has made into your machine and integrate them, so merge them and make sure there's no conflicts. Second, confirm that it works on somebody else on another machine, typically a dedicated integration machine, and that all the tasks pass 100%. And then third, make those changes available to everybody else for when they integrate. Share your changes with everyone else. What tools get wrong is they do it backwards. I can't believe they do this. They have you integrate your code and do all the changes. Then they share the results of that with everybody else. And then they check to make sure it works. So if there was a problem during the integration, which there not too infrequently is, the test might fail or something like that, then everybody else has got bad code. And if they try to integrate with that bad code, their software fails. And now they don't know if it's their code or your code, and human nature being what it is, they're probably going to blame somebody else and not fix the problem. And then you end up with builds being broken for days on end. We've all seen it. Don't do it. It's painful. So what we need is a continuous integration process, a technique that ensures the code is known good before it is shared out with everybody else. It's just that simple. And it's actually not even that hard. Now, there are various ways of making this process work in various tools. I'm going to share the one that I like to use with Git. And now again, most continuous integration tools will not do this, right? They will share your changes before they confirm they work. And that's just no good because you can't count on the code that you're getting to be actually good. So when there's a problem, you tend to not try to solve it, but just blame other people. Again, human nature. So I just do it manually. It's actually not that hard. I've got some scripts in the Automatopia repository to help with this process, but integration does not need to be done automatically. All you need is another machine that you can go run your build on. That's really all there is to it. These CI tools, all they're doing is running builds and emailing about the results. But if the build is known good and you have a process that guarantees that you never share bad code, you don't need the email part, and running the build is just a matter of typing Jake enter. So not that hard. So here's a way of making sure you never, ever share broken code with anybody else using Git. If you're using a different repository, there's other choices. Check out this essay that I wrote a long time ago about how to do it with non-distributed repositories. It's called Continuous Integration on $1 a Day, and it uses a rubber chicken, and it works really well too. Check it out. All right, well, if you're using Git, again, what we need to do is make sure that the code works before we share it with everybody else. We can use the Git's branching structure to enable that. You need some sort of master repository that has your known good code in it. That's typically called an integration machine. So you'll set up a repository on the integration machine with an integration branch. This branch is your known good branch. You'll also set it up with a development branch for each development workstation. These may be anonymous workstations or they may be named. Here I'm just calling them Dev1 and Dev2. Then you set up each development workstation with the same branches, and you develop in those development branches. So when you're ready to develop, you copy the code down from the integration machine using git pull. You do your development. And then you push the changes back to the integration machine, but rather than pushing them to the integration branch, you push them to your local development branch. What that means is that when other people get code from the integration machine, they're still getting the known good integration branch, not your dev branch. Then you go over to the integration machine, confirm that the change worked, and then, if it has worked, you merge it back to the integration branch. This process creates an environment where your integration branch is always 100% guaranteed to build and pass its tests. Whenever you integrate with that branch's code, whenever you pull it down to your development machine, you are guaranteed to have it work. It's just literally impossible to have a bad build doing this, and it's simply because you're running your tests before you share your code. You integrate, you test, and then you share it out to everybody else. Now, the actual Git commands to do this are fairly straightforward, but I do have included in the Automatopia repository a CI script that shows how to do it. And I've got a simulation of that kind of environment set up here. So here we have an integration machine, and here we have 2 development machines. And the CI script, I've copied that over, and it's ready to go. So what you're going to do is you're going to work on the development machine. Here we have our development machine here. We've got everything working. And let's say we add a file. I'm going to add new file right here. So now you can see we have new file.txt has been added. But because I haven't integrated it, it's not available over here on the dev machine 2. We don't have new file yet. So what we want to do is integrate this code back to the known good integration machine so that everybody else can get it when they're ready to get it. The way we do that using this CI script that's in the Automatopia repository is first we confirm a good build. So I'll do that. Then we run CI pull. That gets the latest changes from the known good integration branch on the integration machine. And it will check to see if you've checked everything in. In my case, I forgot to check in that new file. So let's go ahead and do that now. Okay, that's checked in. Now let's look at our quick reference again. We've confirmed the good build. There it is. We should be able to say CI pull, because this is going to do the integration for us. It's going to check that everything's checked in, then pull from the integration branch. And once it's done that, we've merged the integration branch into our current branch. We're going to check again to make sure that that didn't break anything, that we don't have any integration conflicts. We don't, so everything's good. And now we're going to push our code to the integration machine, but not to the integration branch. We're going to push it to the dev1 branch so that we can test it on the integration before we share it out with everybody else. So what this is going to do is check to make sure there's no unchecked in changes, then push that to the dev1 branch on the integration machine. Over here on the integration machine now, assuming that you've got a shared team room and the integration machine is in your environment, you just walk over to it, or you could log into it over the network, however you want to do it. Now what you're going to do is run promote. So in this case, we'll say CI promote dev1. So what this is going to do is it's going to switch to the dev1 branch, test the build to make sure it's good, and then once it is known good, it's going to go ahead and merge and prompt us to put in an integration comment. And this is our opportunity to sort of summarize all the different commits we've made on our local branch. So I'm just going to call this an example of integration, save that out, and it's going to go ahead and merge that change back in to the integration branch. And now it's available to everybody else, and it tells us the integration is okay. Now, on the other machines, when we're ready, we can integrate with that. Again, CI pull will bring down the changes and integrate them. And now you can see right here, there's that new file. And if there's any problem with our build at this point, it's because we know there was an integration conflict. Because not a problem with the code that somebody else checked in, but a problem with the way their code interacted with our code, because the integration code is always 100% known good. It is guaranteed to work because you cannot break the build, cannot break the integration build with this process. Now that we've taken care of our teamwork needs, we can start focusing on regular development workflow. The first piece I want to bring in is linting. Linting is static code analysis. This is having a program look at your JavaScript and make sure you didn't make any dumb mistakes like misspelling a variable name or leaving out a comma or a semicolon or whatever. There are many tools out there that will do linting of JavaScript. The original was Douglas Crockford's JS lint. That was forked to make a less opinionated version called JS Hint, and there's also a new one called ESLint. I am currently using JS Hint, but of course I'm always on the lookout for a better tool. I like JS Hint though because it seems to have a nice balance between performance, because linting can be slow, and not being too opinionated. Again, as with everything in this video though, please use whichever tools you like. The important things I'm trying to convey here are more about the approach you follow and the way you think about these problems than the specific tools. To lint our code, we're going to need to add that to our automated build. What we'll do is we'll go into our build file right here, and we'll add a new target called lint. And then, because these build files can get complicated, I'm going to go ahead and create some sections here. We'll have a lint section and a version sections, or let's make them all verbs. Lint and check version. And then here we're going to have a lint task. And I'm actually going to have this lint task depend on two things, because we're going to have two types of linting that we're going to do. First, we need to lint our build scripts and all of our node code. So I'm going to call that lint node. But we're also going to want to lint our client-side code, our front-end code. And actually, the options we use for those two situations are going to be somewhat different. So I'm going to have two different lint targets for those two different situations. And I'm not going to have this task do anything. It's just a way of organizing our other tasks. I'm also going to add to these tasks, now that we're in here, I'm going to add some descriptions. I'm going to say that this is about linting everything. This is going to be about, eventually it's going to be about linting and testing. And this will be check versions, or check node version. And putting this description above each task, it just gives Jake the ability, when we pass in -t, to tell us which options are available. It's just a helpful bit of documentation. And this really nice, concise documentation is part of why I like Jake over Grunt. All right, now we've got a lint target. But we don't have it doing anything. So if we run lint, if we run Jake, it will complain there is no task called lint node. So let's make a new one. Make a lint node target, and we'll just say that right here, that's where we're going to lint our Node.js code, and we'll do the same for our client code. And when I run that, we see that the linting tasks are running, although of course at this point, they aren't doing anything yet. All right, now that we've got those placeholder lint tasks in place, we need to install JS Hint. And I actually have a NPM module that will work nicely with Jake in this sort of simple build style that is for linting. So I'm going to install that. npm install. It's called simple build JS Hint. We're going to want to save that to our package.json, and we're going to want, again, ignore scripts. Once that's done, we'll check it in, and we'll rebuild everything to see if there's any binaries we need to ignore. But as usual, there's not. Now that that's been added, we can just require it. And run it by calling jshint.checkfiles. Now, of course, you don't have to use the simple build-jshint. You can run jshint directly. The simple build provides a nice interface to jshint, because jshint's programmatic API is not great. So as before, what we do is we'll pass through a complete and a fail, and we'll tell we'll tell Jake that this is an asynchronous task now, and we'll give it a list of files. In our case, we're going to want, really just everything in the build directory. And some options, one of which is going to be tell it that this is node code that it's linting, and some globals. And some of the globals we'll need is Jake, this desk description command, task, basically all the Jake globals. If you're not familiar with JS Hint, this is just saying that don't complain about seeing these global variables, but do complain if they are changed. We can use them but not change them. If we wanted to be able to change them, we'd say Jake true. And then so we get nice output. Let's just change this to process.standardout.write. And we should now see our code lint. There it goes. It's linted all of our node.js code, and it looks like it linted 5 files. So now if we remove a semicolon or forget a semicolon, lint should complain about it. And it does. There it's saying build.jakefile.js, line 38 is missing a semicolon. So there you have it, nice little linting. Now, again, these build files tend to get really complicated. So what I like to do is factor out our configuration options into a config directory. You can see I created one here for the CI script. Didn't go into those details, but that's where this came from. I'm also going to put these linting options into a config file as well. This is already set up again in the Automatopia repository, and I'm just going to use that here. I've got a file called jshint.conf.js, and that exports node options, client options, and so forth. It also uses an object merge package that we'll have to install in npm. There, now that that's installed, we can use it. These are just some options that I like. You are, of course, welcome to use whichever ones you want. And I've pre-populated it with some common globals that we'll need. The merge here, by the way, just says, for our node options, take these universal options and add node:true, and same for the client options. Start with our universal options and merge in browser true. So now that we've done that, I should be able to come into here and say that our options are, well, let's require from the config directory our jshint config. And then I can say that our options are jshint config dot node options and jshint config dot node globals. Let's see if that works. Looks like it is. Now we can set up the exact same thing for our browser code. We don't have any browser code yet, but we're about to. jshint.checkfiles. Our browser code is probably going to go into source client ***. That means everything ending in JS in any directory under the client directory. And our options are our client options, and our globals are our client globals. Need to pass in complete and fail and tell Jake that this is an asynchronous task. So it waits for those functions to be called. And now we have proper linting. Again, what this does is catches common mistakes. Simple, silly errors that in another programming language might be caught by a compiler, here are being caught by our linter. And it will save your bacon over and over again. And that's why I consider linting one of the essential aspects of your JavaScript workflow. In this next section, we're going to look at front-end modularity. Modularity is simply the ability to split your program up into multiple files or modules. And in Node.js, we do that with these require statements that you see here and that we've used in our build file. Well, JavaScript, as I'm sure you know, doesn't have any built-in mechanism for modules, at least not until ES6, which isn't widely supported yet. But there are lots of tools out there that will give you that ability, and my preference is a tool called Browserify. It basically gives you exactly what Node has, the ability to use require statements, except it works in the browser. And the way it works is by having a build step that takes all of your files and concatenates them together with a bit of magic to make it look like you are doing require statements. But what's really happening is that you've just loaded everything in the browser and things are referring back and forth to each other. Now, this is nice because now when we're developing, we don't have to worry about having everything munched together, and we can put disparate concepts, separate concepts in separate files. That's extremely useful as a developer once we get into anything but the most trivial of programs. So to explore this question of front-end modularity, I brought in some more code from the Automatopia project. And again, go there for all of this code and to have a seed project to use to start your own projects. This, the example that it comes with is very bare bones because it's more about the automation than the actual example. But what we have here is a little validator that when we click the button, a field turns pink. And I've also set up a new build target so that we can type Jake run and it will start the server so that you can load that. I'm not going to go into those details, but again, see the Automatopia repository for more information about that. So here's our index.html that we're seeing. It's really drop dead simple. And what we're doing is when that button is clicked, we're calling a validate function, which is in turn calling example.validate text field. That's stored in example.js, which we refer to here. And here in example.js, what we're doing is we're basically setting up a global namespace on window.example. We're setting up an object on window.example and putting this validate text field on it. So this is the non-browserify way of having a separate file that we can refer to. Now this gets pretty cumbersome over time. So what I'd like to do is migrate this code over to use the browserify format. By the way, this code is obviously extremely trivial and actually not even correct. Don't worry about the code though. This is more about the idea of bringing in the require function. So let's imagine that we wanted to split this up into multiple files. Now it's really small and this isn't really a real world example, but let's just roll with it and pretend that that may be true. What we're going to do is we're going to separate this piece right here out into a constants file. So what I want to be able to do is say var constants equals require constants.js. And then down here, instead of saying required field class, I want to say constants.required field class. So we'll take this and we'll put it in that constants directory. So I'll make a new file. And we'll go and put the variable in there. And the way it works with browserify is that anything you want to be accessible by the people who require your file, you put on the exports variable. This is a magic variable that browserify creates for you that is unique to each file and just sort of is how the require statement connects. So when we do this, now the result of this require function is all of the exports values that we set in this file. So now we can take this out and say constants.required field class. Now that does require us to take out our global and replace this with an exports as well, and we'll need some way of making that connect here in our HTML. We'll get into that in a moment. Now if I run this, you are going to see a couple of things happen. First, it builds just fine, and you can see that it's being linted. But when we run it, it no longer works. Require is not defined, example is not defined, it's just a big mess. And that's because the browserify code, this common JS format that browserify uses, is not valid JavaScript. It needs to be run through browserify, the browserify preprocessor, and turned into an actual file. So let's go ahead and get that set up. First thing that we'll need to do is we will need to go ahead and install browserify. Let me check in what we've changed so far. Now we'll install browserify as normal. As always, we're going to ignore scripts and we're going to add it to our package.json. And confirm that there's no binaries that we need to ignore. As usual, there's not. And now we should have browserify ready to go. If we run it out of our node modules directory, there we go. There is browserify. So now what we need to do is have this run. What we're going to do with browserify is we're going to give it an entry point, in this case example.js, and it's going to look through those files, find all the require statements, and concatenate them together, and spit it out into a single file, which is typically called bundle. What we need to do though is have our automated build put that in a place that's useful for us. And the place I usually like to use is I like to have a single generated directory that is in our root that we put in our git ignore so that those build artifacts are not checked in to git. So I'm going to add the generated directory to our git ignore, and then I'm going to modify our build to have a new build target that will use browserify. Now we're going to want this build target to be something that you can run independently, so I'm going to go ahead and give it a description. And it's going to have dependencies, but not any actions of its own, because really what it's going to do is just turn around and prep the distribution directory, build the client directory, and build the server directory. So now when we run Jake, we should see, well, it's going to complain about those tasks not being there, but we should see it show up in our list of options that we can run. So there it is. Now just put in placeholders for those 3 tasks. So with those placeholders in place, we should see it running. Of course, it's not doing anything yet, but we will get to that in a moment. I'm going to go ahead and check this in. Now we're going to get to the browserify. We're going to get back to that in a moment. But before we do that, I want to write the aspect of the build that is going to create this dist directory for us and copy over everything except for our JavaScript. We need to copy over index.html, our server code, and the thing that starts the server, this run.js right here. So to do that, the first thing we need to do is delete everything inside the dist directory, and we also need to ensure that the dist directory is present. So I'm going to go ahead and delete this example that I created earlier. And what we're going to want to do is we're going to have prep dist directory depend on that generated dist directory. And then using Jake's built-in directory task, we can add that here. So what will happen is when it tries to run build, it will first run prep dist directory. When it tries to run that, it will try to run this task. And that task is going to be automatically created to create the directory and any directories above it, any enclosing directories it needs. So now when we run our build, we should see that generated dist directory come back. As things change, we don't want to leave any existing files in this dist directory. So what I'm going to do in this prep distr is delete everything in there. And to do that, we're going to need a new Node module that called shell.js. And that's just because Node's built-in file manipulation functions are not that convenient. Shell.js gives us the ability to do Unix-like file manipulation, sort of the same kind of stuff we do at the command line here in our build script. Install shell.js, once again ignoring scripts and saving it to our package.json. And I'll commit that, rebuild it to make sure there's no binaries, and as usual, there's nothing to add to our git ignore. Now I can import it, and now we can use it. So what I'm going to do in this prep distr is just remove, well, I'm just going to remove the dist directory. So rather than having created that, I'm just going to say prepping is making sure that there wasn't one. So when I run build now, we should see that dist directory disappear, and it did. Now, before we move on to copying things in the client and so forth, you're probably noticing that we're repeating ourselves all over the place. And this is really common in a build script where you start having to manage paths and it gets ugly. And I used to just put those all in constants at the top of my build file, but even that would get unwieldy. Nowadays, what I'm doing is creating a config file that has all those paths in it. And I call it, unsurprisingly, paths.js. So I'm going to just define our exports variable as having a distr, which is going to be generated/dist. And up here, I'll import it. Which means that now down here, I should be able to say paths.distr, and here, paths.distr. And now I'm not typing in the same string all over the place and I don't have to worry about typos messing things up. And if I ever need to change that, which doesn't seem that likely, but in case I wanted to, there's only one place to make the change. Our build should still be working. It's saying it can't find the module paths though, so it would help if I actually put in the correct path to that module. Let's try that. There we go. Okay, so now our build is prepping the distr by just erasing it. The next thing to do is to copy all the client code into that distribution directory. And with this shell command, the shell module for Node, it's very convenient. We'll just say shell.copy, and we'll copy everything in the client dir that ends in HTML, and everything in the client dir that ends in CSS. And we'll put that in the client distribution directory. So just like the regular command line CP function that you find in both Unix and DOS and on the Mac, this basically says copy all of this and all of this to here. And of course, we're not including everything because we don't want to copy the JavaScript. That is going to get bundled separately. So let's go ahead and add these paths. And run that and see how well it works. We're getting a lint error. I probably left out a comma. Yep, sure did. That's why lint's valuable right there. Okay, there we go. And it's saying dest is not a directory. And the reason it's saying that is because we're not creating that client directory. So what we need to do is have our build client depend on paths.clientDistdir, and we'll add that to our list of directories for Jake to create. Now when we run it, there it's working. And if we look in here, we should see our dist directory with a client subdirectory and our index.html in it. Perfect. Next thing to do is to copy our server code. That's very similar. This time we'll use the -r option to say copy recursively, in other words, copy directories and everything they have in it, because this one's a little bit simpler. We can just say take our server source directory as is. We don't have to strip out the JavaScript, and take our run file right here, which I think I'll call server entry point, and copy that to our distdir. Let's give that a try. It's all copying. Let's double check here. Yep, and now we're seeing our index, our server, and our run. So if we've done that correctly, we can change our run target here to not say node source/run, but instead to say paths.distdir/run, and hopefully see that work. And we've got this run depending on build, so it should run everything or build everything for us. Let's give that a try. Jake run. There we go. It's copying our client code or server code, starting the server, and when we run the server, everything's working. It's not finding our example.js, but it is loading the HTML, and that's exactly what we want at this point. All right, now that we've gotten everything except for our front-end JavaScript copied over, now we can actually do the browserify bundling. So what I'm going to do is have building the client not just depend on the client distribution directory, but also depend on bundling the client JavaScript. So that's going to be a new task for us. That also depends on client distdir. Now technically, because it's being depended on from here, this dependency will execute first. The dependencies only execute once. But I find that it's valuable when I'm designing my build files to not make assumptions about how any particular task will be called. For one thing, I could run this from the command line. For another, I might change it in the future and forget that this is a dependency, an implicit dependency here. It's better to be explicit about it. All right, so this is going to be what's going to bundle our browserify code. So we should see that coming up. There it is. There's our placeholder. Now what I'm going to do is I'm going to bring over a little utility module from our Automatopia repository to do the bundling for us. It's going to run browserify that we've already installed. So here it is, a browserify runner. It's very simple. Most of these scripts are quite simple. It's just convenience. Rather than shelling out to run them, we just run them using their API. And the reason I'm giving them to you like this rather than as modules is that it's easier for you to make changes to them and customize them to your need this way. They really are just simple little things. Okay, so we'll include that. And then down here in our bundle task, we'll go ahead and say browserify.bundle. We have to give it the entry point, the point that is going to start out and require everything else. In this case, it's going to be our client entry point, which is source/client/example.js right here. We're also going to need to say where the bundle.js, the output file is going to go. That's going to be in path.client_dist_bundle, which will be generated dist client bundle.js. So right inside this directory. And we'll pass in a few options to Browserify. We'll tell it to make the code a global variable called example. And we'll tell it to create a source map for debugging purposes. Pass in complete and fail as usual and tell Jake that this is an asynchronous function. And there we go. Hopefully that will work. It says it's bundling it. If we look in here, there's our bundle.js, and yeah, there's all of our code. Fantastic. So I'm going to go ahead and check that in. Okay, now there's just one little issue, and that is, actually it's kind of a big issue. The code still doesn't work. Because we're depending on example.js, but now it's running out of here and it really needs bundle.js. So I'm going to change this to be bundle, like that. We're telling Browserify to make example a global variable, so this should still work. And here we're exporting it, so this might actually work. Let's give it a try. So whenever we say run, it does the build, it bundles the browser code, copies it, copies the server, starts the server, and we run it, and boom, there we go. So that's front-end modules. I think using some sort of tool like Browserify or Require.js to allow you to have your front-end code split up into multiple modules is very important for any serious front-end JavaScript work, and that's why this is also part of my front-end workflow. We've got a lot of good stuff at this point. We've got linting, we've got the continuous integration, we've got a really solid reproducible build, but of course, no development workflow, front end, back end, whatever. No development workflow is complete without automated testing. And front end testing is a bit tricky because we've got so many different environments that we need to target. Of course, we need our code to work on Chrome and Safari and Firefox, but we also need it to work on iOS, and we need it to work on Android, and we need to work it on IE, and blah, 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 blah. A lot of different things. And if you only test your code on one browser, you are going to be certain that it works on only one browser. Or maybe it will work on others. You don't know. So when it comes to testing, I like to use a tool called Karma for automating my cross-browser testing. Karma is really nice because you can fire up real browsers and have your code work. So that's what I'd like to show you next. Now first, let's just go ahead and bring in some tests. I've got some example tests here in our Automatopia package. I'm going to go ahead and copy those over here. Now you'll notice that I put my tests right in with my production code. That is a personal quirk. It doesn't get bundled. It just gets left out of the distribution bundle. So it's not a big deal. And I like having my tests next to my production code. You of course are welcome to do it however you like. Anyway, right here we've got some simple tests that are really woefully incomplete that just make sure that our production code works. And this is using Mocha. You can use any testing tool you like. Mocha and Jasmine are the most popular ones. And it's also using expect.js. And the reason for that is not because expect.js is a great assertion framework. Expect is what actually checks that our tests are working. You know, when we say we expect this, but was that? Expect's doing that assertion. Anyway, expect.js is not a great assertion framework, but it's one of the few that actually runs on IE8. If you don't need to support IE8, I recommend using Chai instead of expect.js because it's a bit better. At any rate, we want these tests to run. So how are we going to do that? And not only run, but fail, because these tests are actually right now set up to test things that example does not actually do. So let's see if we can get that going. Of course, right now when we run Jake, we have failing tests, but it doesn't know, and that's because we don't have anything installed. Let's go ahead and start out by just checking in these tests. And then we'll need to install Karma. As always, we'll want to ignore scripts and save it to our package.json. Once that's installed, we'll also need to install Karma expect for the expect.js support. And we'll want to install something to allow Karma to work with CommonJS and Browserify, because by default, Karma just runs your code in the browser. And again, the browser doesn't know about these require statements, but we're going to tell it to run this client code, not our distribution code, because that gives us much better stack traces and just makes it easier to see what's going on. There's two ways to do this. You can either install Karma Browserify, which will actually run Browserify automatically before it runs Karma. Or you can use Karma CommonJS, which is a little tool I wrote. It's not very complete. It's really just the basics of require, but it's nice and fast and it gives good stack traces. Now, I think Karma Browserify might be a better choice, but I don't have a lot of experience with it. So I'm going to go ahead and recommend Karma CommonJS right now. But if you run into Karma CommonJS's limitations, go ahead and give Karma Browserify a try. So I'll go ahead and install Karma CommonJS. These are two plugins that we'll use with Karma, and I'll go ahead and check all this in. Then we'll need to do an npm rebuild to see if there's any binaries created. And in this case, actually, there are some binaries created. When we do a get status, we can see those. So we're going to add those to our get ignore, like that. And check and modify that previous commit to include them. And there we go. Now that we have Karma installed, we need to run it, but we can't just run Karma. I mean, we could, but Karma requires a configuration file to work. So what I'm going to do is I'm going to run node modules, Karma, bin Karma init. Now you can install a Karma global Karma command line interface, but we're going to have this all running from our automated build, so it's not really necessary. So it'll ask us which testing framework we want to use. We're going to use Mocha. Do we want to use Require.js? Nope. Do you want to capture browsers automatically? No, we'll do all that manually. Again, Karma works by actually running tests in real browsers, and in order for that to happen, you have to open a browser and point it at Karma. That's called capturing the browser. It's asking us where our source and test files are located. We will add that later. Should we exclude any of them? We'll take care of that later. Do we want Karma to automatically watch the files? No, we will do that ourselves with our build file. And there we go. Creates a Karma config for us, which I'm going to move into our config directory. Let's go ahead and take a look at that. As for our base path, it looks like there's a bug here. We'll fix that. Base path is what's our root directory of our project. It's asking about which frameworks we want. Not only do we want Mocha, we also want Expect and CommonJS. So let's go ahead and bring those in. Frameworks are our plugins for Karma. Wants to know which files we're going to load in the browser. We're going to load in our source files. Again, the double star means anything in subdirectories as well. We don't have any files we want to exclude. And it's going to ask about preprocessors. And preprocessors are how it converts JavaScript it doesn't understand into something that can be used in the browser. And in our case, what we need to do is we need to have all of our client code run through the CommonJS preprocessor so that it can be understood by the browser. Basically, the CommonJS preprocessor will handle the require statements and so forth. Then it's asking us which reporter we want to use, which port, colors, logging, AutoWatch, and so forth. None of this is stuff that we really care about. So that's our configuration. Let's go ahead and check that in. Now it looks like it automatically installed Karma Mocha for us, but I don't trust that to have not built our binaries. So I'm going to go ahead and uninstall that. I'm also not sure if it actually put it in our Karma, in our package JSON. So I'm going to go ahead and uninstall those and just note that we've created our Karma configuration file. Then I'll go ahead and install karma-mocha, tell it to ignore scripts, and save dev. Then we'll check that in. Rebuild, look for binaries, and we're good. All right, now that we have Karma installed, running Karma is a two-part process. First, we need to start the Karma server and point all of our browsers that we want to test at the Karma server. And second, we need to actually run our tests. So let's go ahead and modify our build. You knew that was coming. I've got a little utility that is a Karma runner. Again, this is in the Automatopia repository, and you're welcome to copy it. It's licensed under the MIT license. And this will do two things. This has a serve export that will start the Karma server and has a run test export. So we'll need both of those. First, let's go ahead and make that serve target. So we'll need this to be run first. I'm going to call it Karma. And we'll just say serve. And we'll need to pass in the Karma config file, which I'll put in our paths. And then, as usual, complete and fail. And we'll tell Jake that this is an asynchronous task. Karma config is located in build/config/karma.conf.js. And now we should be able to say Jake Karma and start our Karma server. But I did forget to require Karma, so let's go ahead and bring that in. Or require the Karma runner, which will require Karma itself. And that is in the util directory. All right, let's try that again. There we go. So now it's started Karma, and you can see Karma's up and running. And now we can have our Firefox browser run against it. But we can do more than that. We don't have to just do our Firefox browser. We can also do Safari and have that run against Karma. And we can do Chrome and have that run our tests. But we probably want to do more than that. We're going to want run our tests on mobile devices. Let's go ahead and bring up the iOS simulator. And we could bring up an Android simulator as well. There, now we've got Karma running here. And we might want to bring up IE 11 as well, or the other IEs. In my normal development, I often have an IE 8 VM running. So here we have the IE 11 VM coming up, and connect that to our local host 9876, have it hit the same Karma server. So there we go. Karma is up and running. Now we just need to get the tests working. I have to leave this server running, so I'm going to open a new tab. I'm going to check this in, say we've got our Karma server running. The next thing to do is get the code to actually run the tests in. Again, we're going to use that Karma runner. Make a function, a target to run the tests. Have it say testing browser code. And then use our Karma runner to run the tests with a config file, a list of browsers, which I'm going to leave blank for now, and a strict option. I'll explain that in a moment. And as usual, we'll tell Jake that this is an asynchronous task. So once we've done this, we'll need to tell Jake to run the tests. And we actually don't need it to do a build on every time, but let's go ahead and do it just for safety. Have it run the tests. Now that didn't work. It doesn't. The Karma configuration file doesn't pass linting. So let's go ahead and put use strict in here. See if we can get that to work. There we go. Now it's complaining about our task test, which should be right here. I just made a little mistake. Test there. Third time's the charm. There we go. There's our test running on all these browsers. You can see them flashing by. Every time I run our tests, they get copied over to the browsers, actually run inside those browsers, and then we get a report out on each one that has failed. And our tests are failing because, well, our tests are currently set up to expect the validation to not complain when the field isn't empty, and it actually does. So let me bring over the correct code. Again, this is in the Automatopia repository. Run the tests again. And there we go. Great cross-browser tests, and we have our build OK coming out. And that is what I would call good JavaScript workflow. Lots of automation, the ability to really get everybody on the same page and share work on a team and have that reliable, reproducible build. Now, there is one more thing. We are not quite done yet. Remember how I said that we can't check everything into our repository that we depend on, but we need everybody who's running the build to see the same result? Well, all of these browsers are part of that same result. And the browsers, of course, update automatically. So what do we do if somebody's running against Chrome 38 and somebody else is running against Chrome 40 and the build only passes on one of them? How do we make that consistent? Well, to answer that question, I've actually got another piece of this Karma runner, is that it will check that you are running the browsers you said you will. So this option right here will check which browsers you're running. So if we say that we need to run, let's say IE9 on Windows 7, and we don't, the build will now complain. It'll say IE9 was not tested. And that's how you can both document how your build used to work in the past when you go back to it, and share information with your team members about what your expectations are for this reliable build, how you can make sure that you are all testing against the same things. Now it is possible, I put this strict option in here so that you can set this to false, perhaps with an environmental command, and I actually have it set up that way in the Automatopia repository. So it will actually just give you a warning rather than a failure when you don't want to be so strict about it. But I do think that for most teams, setting this to strict is true. So let's go ahead and make one last little change. We will create a list of tested browsers in our config directory that we expect to be present when the build should fail unless they're tested. And we'll have this right here depend on it. Tested browsers here, and we'll require that up here. And let's clean this up a bit while we're at it. Put our utils together and our configs together, and there we go. So there you have it, my front-end workflow recommendations in 2015. We've got a reliable build that's consistent and reproducible across all members of your team. We've got continuous integration set up so that you can share your changes between everybody and combine them together regularly, so every couple of hours, without seeing broken builds. Linting, of course, so any silly mistakes that you make get caught right away. Front-end modules, so you can split your code amongst multiple files. And cross-browser testing, automatic, with, again, a single command. I find this workflow to be extremely useful. There is, of course, more you can add to it, and you might want to use different tools, but being able to do this level of build and test and confirmation all the time with just a click of a button is incredibly valuable and useful. So I encourage you, go take this Automatopia seed project right here, copy it, modify it, add the other stuff you need like minification, and make it your own. That's it for this one. Thanks for watching, and I will catch you next time.